Good morning, good afternoon, good evening, wherever you are in the world, and welcome to our latest presentation in our mobile mapping essentials series. Today we have some colleagues and friends from Horus who are going to talk to us about an additional camera solution for our mobile mapping systems. So welcome to Bas Bouwkes and Dirk Albers from Horus, who are going to present the solution to us. We had some requests over the last period of time about adding cameras and other sensors as well, actually, to the MX7 and the MX9 mobile mapping system. And Horus provides this possibility by connecting the Horus framework technology to TMI, the Trimble mobile mapping field software. So in the first steps, we have been working with Horus, and Horus will be offering a high resolution camera kit that can be connected to an MX7 or an MX9 in the field, and with a workflow that's compatible with the Trimble mobile mapping workflows. So I'm going to hand over now to our friends from Horus, but just to say also, we will take questions at the end, but the way we'll handle questions is if you could please type them into the questions box. Please just do this as we go through, and then we'll have a kind of 15-minute session at the end where we can go through the questions and answer any questions that have popped up. So with that, I'll hand over to Bas, first of all.
Hey, good afternoon, everybody. Good morning. My name is Bas. In the upcoming 5 minutes, I will give you some background information about the company Horus, and from there I will hand over to my colleague Dirk, and he will give you an in-depth demonstration of the HR solution. But first of all, I would like to introduce our company and also the framework where what the basics are for our framework. So next slide, please. So Horus, it's a company. It's based in the Netherlands. We are founded in 2008, and we have a very strong background in the mobile market ever since. And we were global, actually from Indonesia all the way up to Brazil, and also in Europe and EMEA. We have a very strong background. And what we do is we focus on capturing video-based situational awareness solutions. And this means, for example, surveillance applications for police departments, but also capturing street-level imagery for the mobile mapping industry. Next slide, please, Dirk. So what we see now, we see a couple of trends, especially in the geospatial market, is what we see nowadays that our clients want to have a better and real-time understanding of the remote environment. And this sometimes to create smarter and safer workplaces. So the good news is that technology improves every day and becomes more powerful to support this. GPUs are getting more powerful. I'm not sure if you're following, for example, the NVIDIA conference, and they have some really exciting new stuff and new hardware pronounced. So yeah, that's good news. But also AI libraries for companies like Brain Creators are getting better and allowing object recognition and blurring, etc. And of course, the upcoming 5G connections supplying very high bandwidth, and that allows us for edge and cloud computing. So the mobile mapping is responding to this and asking for smarter ways of capturing street-level imagery as well. For example, the demand of high-res imagery for AI purposes. That's what we're in for today. But also the challenge of combining technologies like adding a thermal imagery, GPR data, but also to stitch and stream this immediately, for example, to a virtual control room. But on the other hand, if you combine these cutting-edge technologies that allow, the cost normally a long of R&D process, and at the other hand, competitors are also in the market and would like to do the same. So the big advantage is, well, you should use actually the Horus framework. And the Horus framework, Dirk, could you please go to the next slide, is that we use the Insight framework to make that happen. So our question today is that we believe we can boost the MX sales by making the system a little bit smarter and more versatile. But also, on the other hand, this must be, well, in a very short time to market to stay ahead of our competitors, but also to give an answer to the questions that we got from the market. The market is demanding for HR imagery. So that's the reason why this is our first step, is creating the HR extension. The next slide, please, Dirk. So actually, what does the framework, and what's the reason that we can well deploy such a extension in such a short time, is that our framework is built as a sort of a drag and drop solution. This means the framework, that's a sort of a software platform with a library full of components. In the components, you can drag and drop and build your own pipelines. For example, there is a data grabber that can grab HR data, for example. And that's that's a big advantage of using our system. So we have pre-configured pipelines. You can include your own code blocks, use the AI libraries from third parties. But the most important thing is that we shortened actually the product development time. Well, it says almost a half of the time, but sometimes what other companies takes, for example, 3 months, we can do this in 15 minutes. We proved this by one of the companies called Flair. We created an IR solution. They said, okay, that will cost you 3 months, and we did it in 15 minutes. So this shows the power of actually of the Horus Insight framework. So for today is that we use the Horus Insight framework to build the HR solution, and I would like to hand over to Dirk, and he will tell you all about this. So thanks for your attention. So if you have any questions about the company Horus, please come back to me. You can put them in a question bar, and we will answer them after the presentation. So Dirk, please go ahead.
Yep, thanks, Bas. Let's dive into this extension, and we call this the MX Plus. The challenge, as Bas mentioned, was how can we add more value to these existing products? Since we've seen that people that are working with these products sometimes get requests from clients, hey, you're in the field, why don't you can collect other kind of data, maybe with higher requirements, or with other kinds of applications. And therefore, we took this as the challenge to show that it is possible to add this value. So this was the original idea. Okay, if you combine these products like MX7, MX9, they already collect a very good location and information, have other sensors to do precise measurements. Why don't we connect this with the Horus framework and add the other things Bas already mentioned, like high resolution thermal infrared, for example, to detect temperature differences, especially for utility companies, very interesting if you already have these kind of solutions to measure objects or assets. Temperature difference might inform you about upcoming failures of equipment. That is just one example of adding an extra sensor to this kind of solution. When we talked with Trimble about this, we said, okay, we should focus first on the low-hanging fruit because there is a market need of higher resolution on the imagery part. And yes, of course, there are upcoming requests with other sensors, and that is also what we might do and add in the future. So we started with the high resolution part. And why was that? We saw that there were well, mainly 3 kind of use cases that the market is requesting. And I'll dive in this presentation in some examples of what we did with this extension. But let me first dive into the part of what is then the product, what is the extension. extension is a combination of 3 cameras that can be mounted on an MX9 or an MX7. So the whole kit comes with the mounting accessories. These are high-resolution cameras, 8.9 megapixel each, with a 12.5 millimeter lens. Over the last years, we have a lot of experience with applying this kind of setup for use cases like road inspection, reading detailed information, inspection quality of assets, and recently there was some nice improvement also in the 3D mesh. So if we look at how this is connected, the only thing that needs to be connected to the MX7 or MX9 is just one cable. It's a communication cable where the trigger and NMEA data comes through. And the cameras are connected each with a cable for the data and one for the trigger. That's connected to the recording unit. And this is a Horus box that listens to the operator of the MX product. So if the operator starts a new mission or a run, the Horus software listens to it and starts likewise. And yes, there is also a screen attached to the system. So if you want to make some additional configuration to the extension, you can do that. And important is that this whole extension needs to be powered by a separate battery. And over here you can see that if you have a battery in your car, an extra battery, and you can calculate how many hours you can drive. And this is designed also for capturing 8 hours a day, for example. If we have a look at the workflow, then we try to look at the workflow and leave everything as it is. Like if you have the workflow that the MX9 itself records data like the panoramic images, the PGR files, the planar images, the LiDAR data, and your GPS data. And then the data after recording is post-processed with Planix Postpack. There is one template added to Postpack where you can export also your positional information. And on the Horus extension, the data is collected as HRS data, that's our own format. And with the position fixer, both the trajectory file and the imagery file can be nicely combined. There is that initial stitching. So dependent on where you mount your high resolution extension, that can be in front of, for example, the MX9, but others like to mount it on the back of the MX9. And with the MX7, you can mount it very close to the Ladybug itself. So once you combined the data with the position fixer, you're free to choose which program you want to use the data. You can export the data to single JPEGs with metadata, for example, to upload this in Trimble MX. There is a way to work directly with Horus software, that you have the tools with the high resolution only. And there are some combinations. If you want to combine the data, you can merge the data like the PGR, the panoramic data that comes from the MX9 or MX7, and you can work with that together in the Horus software. Horus software is called Horus GeoSuite. And we know that there are a couple of clients that also are working with Topodot software. So it means if there is the market need, we can also make that export that you can reuse the imagery data within that software too. Really would like to hear from the market what is needed. If we look at the data sheet, well, already mentioned a couple of things. These are 8.9 megapixel cameras each. It's a global shutter, specific, pretty important if you drive fast. We have a lot of clients that drive on highways, so the imagery quality should be good for those use cases as well. The whole unit weighs 3.2 kilogram. And when you look at the data size that's being collected, well, if you record every 3 meter, it's 2.44 gigabyte, and that is almost the same as one LiDAR unit. So let us dive a bit deeper into the demo data. What we did, for example, we made a collection of demo data that is also available. I'll explain later on. We made several setups because we want to give end users the freedom to decide where to focus the resolution. What is the area of interest? So for one approach, it could be focus the 3 cameras in front of the car, in front of the road. Others want to mount this on the back of this system to focus maybe on the road at the back of the car. And for points of interest situations, you can also decide to focus your cameras, left and right camera, more to the left and right towards maybe shops or the utilities. And for the demo purpose, we also made a 45 degrees setup that you can see the differences, what you can achieve with these camera positions. Important to understand that high resolution imagery is mainly used to add that high resolution information to see context information of objects. So it's not the first design to create a very nice combination with a point cloud. It's a kind of addition to see other information besides the thing you already can with, for example, the MX products. Let me dive a bit deeper into these examples, like the road inspection. I think we have, as a company, a pretty long history of collecting and helping others to collect high-resolution imagery for road inspection. And especially the countries that do a lot with visual road inspection, and you have the traditional approaches like sending people along the streets and do inspections with paper and maybe some digital kind of devices, pretty dangerous. So there was a very strong demand in the market. Okay, can't we make this safer and more digital? So therefore we introduced high resolution cameras that even driving 100 kilometers an hour can capture the information of the roads. And as a background, our office is located in the Netherlands. The Netherlands has a very strong history about using an open asphalt structure. That means they have damages a lot about the raveling. That means the tiny little stones are missing. And when that process is starting, it's degrading pretty fast. So it's very important to understand at an early stage how what is the severity of the damages that you can see out there. If you know that in early stage, you can prepare the maintenance programs, and that saves a lot of money. I'll explain a bit more in detail, and therefore I shift towards this high resolution camera setup. As you can see, I'm looking in a kind of 3 camera setup, and we made a blend between the cameras. So I play this video, but on disk there is original data as one single image already available as well. So just for the presentation, within the Horus software, we made this kind of blend, and it's for a user a nice way to do the inspection. So in the last years, we implemented functionality that you can see the tiny details in the road, and to provide inspectors functionality to draw, for example, their observations, and not only click this in the video, but also create directly their attribute information, maybe some a snapshot of it, and it directly creates a geometry on the map. Implemented is also getting the size dimensions of it on the flat surface. And this was a very fast step forward for these kind of inspectors. They still had the knowledge about what is good and what is bad, and they can do their work pretty safely in the office. So the collection part doesn't disturb the other traffic. They got the digital tools to do this. But this is not where it ended, because it is still a lot of manual work for the inspector to enter his observations. So therefore, we introduced also some other functionality to export this imagery to GeoTIFFs, and that is the process that I would like to demonstrate over here. So we made a function to select a certain area of your screen, and well, this can be changed depending on your use case. And this could help us to extract this part of the image and export this to GeoTIFF. So I'm exporting single files to disk, and each image will be cropped out and will be transformed. So if I look on disk, it generates these kind of TIFF files, and it is a GeoTIFF, so it means that every corner of this picture has real world coordinates. And that means if I open this in GIS programs, they support directly the referencing of those files on the right location. And as you can see, I can zoom in on the tiny details and do also the measurements of these objects directly. So this is a nice way of a reprojection of the same imagery, and it is especially pretty interesting what we've seen with AI companies that can run their models directly on top of these images. For example, to do the automatic feature extraction. Where is the road marking? Where are the cracks? That kind of information, and they get the coordinates almost for free. So that is one example of what you can achieve with road inspection quality if you talk about high resolution imagery. Then the other example about the points of interest. As you might be aware that your Ladybird camera can do pretty nice recordings of the surrounding. But we had a lot of questions of companies that say, well, we are mapping databases with all kinds of information of shop names. It's pretty hard to see those in every city at a larger distance. So therefore we added these also within cities towards the buildings. I'll show you some examples later on. And you can imagine that for utility companies, it is the same kind of request. You can see some in your Ladybird data, but if you want to read the utility signs, for example, this is one of the water management company where they can read where the equipment, the assets are out there. I'll show you those in this example. So over here, I have this combination with the an MX9. We mounted this extension in front of the MX9. And you can see if I've looked to the right, you see the same position. So if I try to read this sign, it's not possible with a standard Ladybird. But if I turn my other high resolution camera and open this, then it's possible to read it. So you can see same location and the other camera, and it really helps you to enter that kind of information in a very safe way. And it also works for the shop names and so on. So if I look, for example, to the shop on the left, or what is it, the bar, it's pretty hard to read the tiny details on the walls. And if I switch to the high resolution camera, and even with the one with the neighbors, you can see in these days that they still try to do some business during COVID. And that is pretty hard to see in just that Ladybird. So we discovered a couple of use cases like the points of interest. There are companies that would like to detect maybe opening hours, company names, but for utility companies, it's also important to see the tiny details and maybe also the condition of your assets outside. For example, there is the other one, if I go to the multi-view, where I have some pictures that I would like to share. So I'm opening. It sleeps. I think my disk is a bit sleeping. But then I would like to show the combination of the HR, and that was in the presentation as well. If I enlarge this, for example, this is what the camera can see in that recording. Might be important to read numbers, but also to see conditional information like the asphalt quality and what needs to be repaired and what not. So that was the second part of a use case, what you can do with high resolution data. And the last one I would like to share today is also the way of creating a 3D mesh. If you nowadays look what kind of software is available to create these nice 3D meshes, that could help. There are a lot of companies that use drones, use aerial pictures to create these models. But what we often hear is that the details that the users experience while walking on the street, they can never be captured by those kind of systems. So therefore, we did, together with Bentley, a nice exercise to create this meshes, the same data. The same data you can see over here. So this is created from the images only. So no LiDAR data was used to create this kind of 3D mesh. As you can see, this model was created from pictures and calculated a lot. And this is the result. And if you see that the same details that are in the data sets of the imagery can be seen to this as well. You see even some height differences, and within this model you also are able to do some measurements. So this might be a new approach to adding this high resolution imagery to create those digital twins, and may help us also to create this kind of environments more realistic. And the power that nowadays is available to generate these models is extremely improving as well. Well, and as I mentioned, we also prepared a kind of export that you can reuse your data in other programs like TMX. And dependent on the camera setup, you can make that combination that you are used to. As I mentioned before, imagery with this high resolution and the flexibility that we would like to offer is not designed to create and coloring the point clouds, but it is a very good addition to see the tiny details in relation to the things you already can. So then I would like to dive a bit more in the product. So what is in the package? The whole system is a turnkey solution. So if you buy a system, it comes with the hardware, with a recording unit. The only thing you have to take care of yourself is the battery and the extra battery in the car. It comes with the software, so you're free to create the configurations, to change from camera setups, to make exports of the data, or to directly use it in Horus software. Since we would like to support you, there is also the service level agreement possibility that we believe that this really adds value to you and your clients, and we would like to advise you as the best we can. Okay, what about ordering? The simple answer is please contact your local Trimble reseller. They are aware of all kinds of demo data about the pricing. They're open to help you with this, and we're in close connection with Trimble resellers to support them as well. So that brings me to the summary of today. We started with the idea about how can we add more value to existing products like the MX. We started with the high resolution extension, and we showed you a couple of examples where we believe you can do some interesting business with this extension. We really believe that the Horus framework is capable of doing much more than only the high resolution extension. So maybe we will add more in the future. We're pretty open to hear also your ideas about this, and this HR extension will be sold by the Trimble sales network. I think we're at a part of answering some questions, and I think it's also good to redirect you to, and this will be shared afterwards, I believe, also for some extra information, how you can order these extensions. If you need more support, please let us know. Bas, can you help me with?
Yes, I see a couple of questions coming in, but they're already answered. But I think I have a couple of questions for you as well, Dirk. So for example, if you buy a system like the HR extension, how difficult is it to mount it, for example, on top of the car? And actually, how does it work?
Yeah, well, depending on if you're using an MX7 or MX9, it comes with the mounting accessories. So you first should think, okay, what is the best approach for you to mount it in front of the car or on the back of it? The connection, because it's one single cable, that's maybe the only trick. And you should think about your workflow. How are you going to use the imagery? Are you going to export it to a certain tool? Do you need to have some additional configuration? And with the quick start guide, we help you with these steps. And we also train the Trimble resellers with explaining the possibilities, because we try to be flexible. We have a lot of ways to go, and we would like to share also the experience we had with these kind of applications.
Okay, thank you. There's another question coming in. Can we combine 3D imagery from UAS application with the 3D mesh generated by the Horus product to get a better detailed textured mesh?
Well, actually, in the generation of the 3D mesh was in this case done by Bentley software. So I think that the guys at Bentley side can really inform you about those combinations. And we really believe also in this powerful combination, because from street level, you can collect those high resolution from the street level, and you would like to combine that with data acquired by other systems. I really understand your idea, but I have to redirect you to the guys that are specialists in the software, in this case, Bentley.
Okay, other interesting question. Can this mobile system used on any small ship? So can it be mounted on a ship?
Yes, as long as you, what is small? I'm just thinking of the UAV kind of things, but hey, you have to take care of the weight and so on. Yeah. But yes, we applied a specific for on the canals and having the quays inspected. That is a very good application example of what you can do with the high resolution imagery.
Yeah, and we have there's some examples of certainly MX7s and MX9s on the Trimble website, actually in the Netherlands as well, where they've been mounted on canal boats.
Yeah.
Yeah, since it's a solution from the Netherlands, it should be good on water.
Yes, of course.
So what's the weight of the system?
The cameras itself is 3.2 kilogram. So that is what you mount on the roof of your car. And well, the unit is around, the whole package is around 5 kilogram. That is what you can store in your car.
Okay. Is there a minimum FW compatibility for the MX7 units?
Sorry, I couldn't hear us. What is the minimum?
Is there a minimum FW compatibility for the MX7 units? I'm not sure what
it's talking about firmware, whether there's any kind of restrictions based on the firmware of the MX7. I believe the answer is no. No restriction.
No.
Okay. So if you're using an MX9, is there a way to elevate the camera system in a higher position so the car is not in the image?
Yeah, it depends also how you would like to do. For example, if you want to, the further you mount the HR camera from the Ladybug, the harder it will be to combine images together. So maybe that is not your case. So then there is the configuration that with the lever arms, what you can configure in OSPAC software, that you give the Horus camera itself its own central point. And then, well, you can place the cameras in front of your car, for example, that no car is can be seen.
Dirk, can you also use, if somebody was in, you talked about the configuration of, maybe having them looking forwards or backwards. If I wanted to do both, is that a possibility as well?
That is a possibility. So then you have to save two separate configuration, camera configuration files, software-wise. So that is just another export while you post-process your data.
Okay, thank you.
So that gives you the flexibility.
Okay, other question, actually there are two. So how precise is the 3D mesh creation?
Well, these are the first steps of the creation of this 3D. It was, in this case, not tested on that kind of accuracy. It's a very good question, so I'll have a closer look at that.
Okay, so are there things or places where the 3D meshes, the 3D mesh creation has a little bit trouble, like crowded places?
Yes, sorry, and the question is?
Oh, the question actually is the 3D mesh creation has a little bit trouble, for example, like crowded places? So.
Yeah, that is yes, of course. The camera sees what is out there. Yeah, if there is the opportunity to do your data collection on the times that there are not that much people on the street, that is well advisable. And I'm not sure currently what is the status of removing automatically kind of things from the imagery part, and because I've seen there's also a lot of cleaning in progress on the 3D mesh creation, but I have to talk to the specialists what are the possibilities over there.
Okay. Do you have any developments specific to railway applications?
Well, the same technology can be applied on railways, what we did also in the past. The whole trick is if you can mount your MX9, for example, and I believe maybe Peter can add that you have also clients that do that kind of data collection, isn't it?
Yeah, we've done some, we have some customers that have collected data on railways with an MX9, and in fact, we have a special railway mounting kit for the MX9 that has a little bit kind of different shock absorbing characteristics compared with a vehicle, a car. Yeah.
The only thing you have to be aware is what is the speed that the train will drive. There is we advise if you drive maximum of 90 kilometers an hour, with the distance of each 3 meters, you can collect very nice imagery. If it is faster, well, you need to have a closer look at what is then the orientation of your camera, and what in the end do you need to capture each single meter. So you have to be aware, specific in the train environment, what is the use case.
Could you just say something about how the system operates, kind of how is the integration with the Trimble system? Like, what does the operator need to do to make the whole thing work?
Yeah, well, the thing is, as long as he connects the cable, we make use in this case of the TMI API. So that runs on the Horus system. Therefore the Horus system listens to the signal that comes from the MX products. So the operator only has to do the same things as before, as long as he convinces himself that the cable is connected and that the Horus system is turned on.
Right, thank you.
Yep.
Okay. Other question, Dirk. Is there an optimal time of day to generate 3D meshes? And particularly because in Arabics, time of day matters based on shadows. Is this product effective the same way? So what's the best time of day to create, to capture the imagery for the 3D meshes?
It's a good question. As I showed you in the examples, we had also sunlight coming from one direction. That is the real-time situation. So as you can see, this generation of 3D also displays shadow, and I'm not sure if that's a virtual shadow. I think to give you a good answer on this, I have to talk also to guys, in this case of Bentley, that have a lot of experience with this 3D mesh creation. But I would think that, well, if you want to have a realistic 3D mesh, then there will always be that kind of shadow sunlight on it, as it is in real life, and that is, well, real context capturing, isn't it? But I'll check with the guys if there is a kind of optimum.
Okay. Question: where will the Horus imagery, will this be stored internally in the MX7, or is there a separate device needed?
This will be stored on the Horus device, so it's a separate device. As I mentioned, it's a recording unit. That is a Windows unit, so it will be stored on that drives on that disk. So it's not stored on the MX system itself. We try to get to leave the scope as clear as possible. Only the cable is the connection between the two systems.
Okay. Thank you. Would the HR camera be capable to determine the species of trees by looking at the leaves? Do you have any experiences with this?
I think then I should pass this question to those AI companies we work with. It is always a kind of use case. Okay, how is the data recorded in general? And that is also the reason why the high resolution imagery is this popular, that AI companies discover those self-learning patterns and really need better resolution nowadays. But to answer this specific question, I think I should get you in contact with one of the AI companies who work closely.
Okay. Other question: can the Horus cameras be pointed in any direction?
Yeah, I have to think. Well, at least you would like to see the pixels on the target of the area of interest. So if you mount this on a car, yeah, well, of course, it makes sense that you would like to see something on the road and not the car itself. So you are free to, well, and you have to think, yeah. We designed this mounting. That was why I was thinking about this. We designed this mounting to be flexible, to point the cameras to above, down. So if you want to point 3 cameras up front, don't know if that makes sense for that application. But you're pretty free to mount this within, and please have a look at the mounting of the cameras. Then you see what kind of configurations can be achieved by the rig that we supply with this kit.
Perfect. I think this is the last question. Yeah, it is.
Okay.
Okay.
Okay, so So thank you to Buzz and Dirk, and thank you to everybody who's taken the time to attend this session. And the session has been recorded and will be available on the Trimble website, let's say within the next 24 hours. So if you have colleagues that missed and would like to watch this, then the recording will be available, as will be the PowerPoint slides themselves. Thank you very much.
Thank you.
Yes, thanks.